Now in step 2 we shall be observing that the gaseous sodium will undergo the loss of electron forming Na positive, and as already discussed that the positively charged metals after the loss of electron, they are called as cations. So here we have got sodium cation. Now remember this, that since electrons which are present in the valence shell of sodium atom are being taken out forming a cation, that means initially when the electron was present in the valence shell, it was held through an attractive force with the nucleus of sodium atom. That means when we are taking out the electron from sodium atom, the attractive force between the nucleus of sodium and the electron, that has to be made zero, and which can be done by the provision of energy. So we provide sodium gas an energy which is called ionization energy, such that it should be converted into sodium cation. Now here ionization, again plus why I am writing, because the system or sodium gas is absorbing energy to undergo the loss of electron from its valence shell. So we will be representing here positive sign before IE, which is representing ionization energy. So here basically ionization energy can be defined as, so ionization energy is the energy required to take electron from valence shell of a gaseous isolated atom. So here also in the step 2 we are observing that sodium is in the atomic state, isolated form, it is in the gaseous state. So on the provision of energy, that is ionization energy, it will undergo the loss of one electron from its valence shell, and in case of sodium it has got only one electron in its valence shell, so it will convert into sodium cation and one electron will be liberated out. Now in the next step, the electron which has come out from sodium atom will be added to chlorine. But remember one thing, that either removal of electron or addition of electron can only be done to an atom when it is isolated and in the gaseous state. Here we are observing that Cl2 is although gaseous but is not isolated, it is diatomic here, it's not isolated, so we cannot add electron of sodium into Cl2. So the very first step which will be involved here is that we will have to convert this molecular chlorine or diatomic chlorine into monoatomic, that is isolated state. So Cl2, which is non-isolated, will be converted into chlorine which is isolated. This is non-isolated, although it is a gas. Cl is isolated, it is also a gas. Now since we are separating two chlorine atoms which are held to each other, that means we have to overcome the force acting between those two atoms. Now to overcome the force, again we need to provide energy, and that will be called as heat of dissociation. We are basically dissociating the bond between two Cl atoms, so we are calling it as heat of, Q is heat, D means dissociation. Here plus sign will be used. Why? Because again we are adding energy to Cl molecule which is in non-isolated state to convert it into isolated form. Here Qd is representing the heat of dissociation. So moving ahead to another step, that is step 4, we observe that chlorine, which is isolated as well as gaseous, will gain electron of sodium and will convert into Cl negative. Here as electron is being added to the valence shell of chlorine atom, means an electron which is isolated from the attractive force of the nucleus will now possess an attractive force, hence there will be loss of energy, and that energy is called electron gain energy, or we can call it as electron gain enthalpy. Basically enthalpy represent the heat content of a system, means energy, so we can call it as electron gain enthalpy or electron gain energy. So we shall be writing Q Eg. Here Q means heat, Eg means during electron gain. Since we had been using positive sign for the absorption of energy, here energy is being liberated, so we shall be using minus. Here Q is representing heat liberated during electron gain.